Hello and welcome to the Extended Greg YouTube channel. I'm Greg, and on today's show we're going to be installing Alpine Linux on a Raspberry Pi. It's an introduction into embedded Linux, and we're going to be using it for future projects, so be sure to stay tuned. We're about to get extended. So today we're going to be using the Raspberry Pi Model 3B. And this is more than enough processing power for anything that we're going to need today, but the key thing is that it has an SD card that it uses for storage. So I've taken the SD card that we're going to use and I placed it inside of the SD card reader in our computer. And the first thing that we're going to want to do is we're going to want to clean it. That way there's no previously installed OSs or undesirable partition types that could interfere with our ability to run Alpine Linux. So to do that, we're going to hit the Windows key and we're going to type in CMD. Now instead of just opening the command prompt directly, we're going to run it as administrator. Once it launches and we confirm, we're going to type in diskpart. When it comes to the diskpart prompt, we're going to type in list disk. We want to make sure that we're cleaning the one that we intend to, and not a different drive that may have data that we want. So we see that disk 0 is our OS because it's the larger of these two in this particular case, and it usually is. And then disk 1 is the SD card. It's possible you may have more, but in this case we want to select disk 1. So we're going to type select disk 1. We hit enter and now disk 1 is selected. And we're just going to type clean. And we see that diskpart succeeded in cleaning the disk. So the next thing that we're going to want to do is partition and format our drive. So to do that, hit the Windows key and type disk, and then we'll be able to create and format hard disk partitions. So we're going to click it here. That will take us into disk management. We see that there's disk 1 has 29.81 gigabytes of unallocated space. We're going to right click and go to New Simple Volume. For the first few prompts in the wizard that opens, we're just going to leave the defaults. When we get to format this volume, we're going to click and we're going to select FAT32. FAT32 is needed because it's going to be a bootable drive, and it needs to be able to boot off of it, which NTFS is not capable of doing. We're also going to label it, and we're going to call it Alpine. A quick format is just fine for this. It'll save a lot of time, and it's not really necessary in this application. Once we hit finish, we can then wait for it to finish formatting. And it did open up the drive in this case, but if we look at disk management, so if we look at disk management, we see that it is healthy and the partition is formatted as drive D. So we can X out of that. Now we want to download Alpine Linux. So I just did a search in a search engine for Alpine Linux, and we see it gave the options to download it. So I've navigated to that page, and there's a couple of flavors that we can choose from. But the one that we want in this particular case is a Raspberry Pi ARM v7. ARM v7 works for all Raspberry Pis except for the first generation, which we would have to use ARM HF. And we do have the option to use a 64-bit version as well. In this case, we're going to choose ARM v7 because it has broader compatibility. So we can click it to download, and we see it starting, and it's only 96 megabytes in size. But the extension is .tar.gz. So the download just completed, and we're going to want to open this file. But because of the tar.gz extension, we're going to have to use a separate program. In this case, I'm using WinRAR, but we could also use 7-zip to do the same thing. So we don't need to look at any of these files in particular, but we do need to extract them all to the SD card. So I'm going to click the double dots at the top and hit Extract to. We'll then choose our SD card and hit OK. It will then start extracting the files to the SD card. So now it's completed the extraction. We can close out of WinRAR or our 7-zip, and we can minimize the browser. We can now see that the files that were in the archive are now in the root of the directory on the SD card. So let's go ahead and eject it. So we right click on the icon and hit eject. So now we can safely remove the SD card. So we're going to take the SD card and we're going to place it inside of the SD card slot. And now we're ready to boot. The nice thing about Alpine Linux is it doesn't require any special booting partitions in order to be able to run. Just by extracting it to the root directory, it has all of the files needed in order for Raspberry Pi to be able to boot from it. Okay, so now we have the Raspberry Pi connected to an HDMI, Ethernet, and we have a keyboard plugged in as well. So the last thing that we need to connect is the power. So when I plug in the power, we see that it boots up, has the classic rainbow logo, and then it starts to boot. Now the boot process is actually very fast, and that's because it's loading everything to RAM, but in this case we don't have anything installed. So we're going to log in. The default login is root, no password. The first thing we want to do is we want to update our system. So we're going to do apk update. It says packages available. That's fine. It's reading it from the internal SD card because we haven't initialized a network connection yet. So the next thing we're going to do is type Setup-Alpine. This will take us into the configuration utility that will get all of our initial settings all established. So it's asking us for our keyboard layout. In this case, it's US. Do we want a variant? No. So we're just going to type US once again. It's setting the key map, and it's asking us if we want to set up a host name. So let's call this our test Alpine. It's going to error out and say that it can only contain lowercase letters and numbers. So let's do that. So it's asking if we want to initialize our network port. In this case, Ethernet 0. So we're going to keep the default, so anything that you see in brackets is the default. So we'll just hit enter. And it says, do we want to use DHCP? And in this case we do. And again, it's the default, so we'll hit enter. Now it has wireless LAN, but we don't want to set it up. So we're just going to type done. Then do we want to do any manual network configuration? And in this case, no, which is the default. So it obtains an IP address, and it asks us to change the password for root. So I'm going to set a password and retype it. Now in this case it said the password was too weak, but in production you would definitely want to set a strong password as a matter of best practice. But for this case, it doesn't matter. So now it's asking for which time zone are we in. Now I happen to know my time zone, but if we didn't know it, we could type the question mark in order to get a list. So I'm going to use the US Eastern time zone. Next it's asking if we want a proxy server. In this case I don't have one, so I'm just going to go with none. It's going to ask which NTP client do we want to run, and I'm going to leave the default as Crony. Now NTP is required because the Raspberry Pi does not have an internal battery to be able to maintain the clock when it's powered off. So NTP time setting is definitely important. So next it's going to ask us what mirror that we want to use in order to be able to download packages. We're just going to choose the first option. So in this case it's not showing the full list. We know we want to go with option 1. So we're going to hit R, and then we're going to choose the default, which happens to be option 1. So it updated its list, and it's asking if we want to set up a user. In this case, we're going to stay as root, but in production, we may actually need to set up a user in order to be able to securely execute our functions. So let's just stay with no for now. So now it's asking which SSH server do we want to use. And SSH is useful in terms of being able to remotely configure the Alpine Linux installation, especially if it's not going to have a monitor attached to it. So we're going to stick with the default, which is OpenSSH. So allow root SSH login. In this case, because we only have the root user, we wouldn't be able to get in if we weren't able to access it. So there's two options available to us. We could do prohibit password, which would require a key to securely access the system. That way somebody can't just guess a password. It's going to be extremely long. And that's the most secure way to do it if we were going to do it this way for production. But because this is just for us to be able to test and experiment with Alpine Linux, we're just going to type yes. But this is, again, very insecure. So enter SSH key or URL for root user. In this case, we're not going to do this. We're just going to leave it as none. So it's going to generate new host keys, and this is to be able to securely encrypt the password and communication traffic. So it says no disks are available, and it lists our current disk, which is our SD card. We don't want to install it to any disk, so we're just going to say no. And then it asks, where should we store the configs? Now this is very important because this is the only way that we can preserve configuration changes between reboots. So we're going to leave it as the default, which happens to be the SD card. Also, the APK cache directory, we're going to leave that as the default as well. So now, once we finish, if we were to reboot the system now, none of our changes would be preserved. And if we make a mistake, that's a good way to clear it and start again. In order to save all of these changes, we're going to type lbu commit. And that will save the changes to disk. So now if we were to reboot the system, all of the changes to this point, up until when we ran lbu commit, would now be saved and would be restored on the next startup. Now since we're done initializing the system, we've set up our network as a function of it. If we do ifconfig, we can see our current network configuration, and we see that we have an IP address for adapter ETH0. So we should be able to ping Google. And we get a reply. So we have network configuration. So let's say we wanted to install a package. In order to do that, we would use APK Package Manager. So the first thing that we want to do is do APK Update. This will update our list of packages to be able to give us all of the available options. So next, let's say we wanted to add the package Nano. Nano is a text editor that's very useful for configuring the system as well as modifying scripts. So let's do APK add Nano. We see it installed Nano, and it's saying it's using 18 megabytes or megabytes in 48 packages. So once we install that, if we were to reboot the machine right now, we would lose that installed package. So to make sure it gets preserved, and after any time we modify the system and want to preserve those changes, we do lbu commit. So now it will persist through reboots. APK can also be used to search for particular packages. So if we do APK search, we could look for Python, for example. And it will give us a list of packages that contain Python. But we're not going to go into that today. So let's reboot our system and make sure that it still works. So now we see it's successfully booted up. It's kept our hostname, which was Test-Alpine, and we can log in using the credentials we set before, which in this case is root and the password that we set. So now we're in, and we can edit a file using Nano. So we're going to edit a file called test. And we see it opens up, and we can do hello world. We can save. We can then display the contents of the file to see that it wrote. If we reboot again and log in, we can now see when we do cat test, the file doesn't exist because we didn't save it using lbu. So it's now back to the state that it was the last time it booted up. So to shut down an embedded system like this, it's very easy. All you have to do is unplug it. And it won't hurt the machine because it's never writing to disk unless you tell it to. So now if we take a look at the SD card that we've just been using, if we plug it into our system, we can find a testalpine.apkovl.tar file. Now this is actually our configuration that we just saved using lbu, and it's generally in the format of the hostname.apkovl.tar. We can actually move this between systems or copy this to other SD cards to be able to apply that configuration on boot up to those other systems. So it's very handy and very portable and very easy to back up. So I hope this has helped you learn how to install and use Alpine Linux, and we'll be using this more in the future as we start to build embedded systems. But we're just going to leave it here for now. So thanks for watching the video today. If you'd like to see more videos like this, check out this playlist right here. Also, if you liked the video, be sure to hit that like button and leave a comment down below. And if you haven't subscribed, please subscribe. It helps me out a lot. And then hit that notification bell. That way you know the next time we're getting extended. So until then, take care.